I'm pushing the button. I said I pushed the button as just then when I said I'm pushing the button. Okay. Can you hear me now? And is the music too loud? More music. Louder music. There was probably a little bit of echo when you first started, but I think it's done now. If you still hear echo after this, scream, shout, yell. Okay. So, today I haven't streamed in a long time, so, hopefully, hopefully I'll remember how to be a camera person again. So today, what I'm working on is messing with particles and weapon trails, so I get to actually play with some graphics for once. I start up the client and show you the current state of things. Add a new game source. Okay. Let's see. Hey Tim, is Hatchery down? Okay, Patrick Client's not talking to Hatchery. Okay. So, yeah, I'm getting used to running the new OBS Studio. Okay, now we're logged in. So yeah, today I'm working on weapon trail things, getting a rare moment to actually play with graphics. So this is kind of the... Oh, there's someone on top of me. This is the this is the current state of weapon trails. Obviously, that's not anything that anyone wants to see. So there are several parts to that. So if you look in really close, you can see that, yeah, the frame rate sucks because we're streaming. But if you look in really close, you can see that it's sort of jerky. It's doing a series of piecewise lines, and the density of particles that are emitted along there is constantly changing. So that's three things that we want to change today. First thing is, it's like every frame the sword is in a new position, and we just sort of draw a line from the position of the old sword to the position of the new sword, and what comes out is, and then we spawn particles along that line. So, that looks really great for when something's, moving fairly smoothly, like like an arrow or something. But when the sword's like got this fast thing going on with twists and turns, having like a series of lines along its path, just that doesn't look good. We don't want to do that. So it just looks very angular. So what I'm gonna do with, and then looking in a little, actually I'm just gonna take a screenshot of this and or do what George calls F12 debugging. Alright. Did we successfully freeze it? No, we did not. Oh wait, we had two running at once. So, I don't know if you can really see it over the stream, but where it's moving slower, the particles are much more. Where it's moving more slowly, like right through here, at the start of the trail, the particles are much more dense than at the end where it's moving fast. So we don't like that. We don't like that it's a series of lines, and we don't. And finally, we don't like that it's just a series of particles. So the three things that I'm going to be trying to do with this today is I'm going to change the interpolation so that instead of fitting lines to the motion to the various positions along the sword arc, we actually fit piecewise quadratic bits to it. So yay math. What that is just basically, you say, all right, here's the old position, here's the new position, and then here's the new position after, like position 1 goes to position 2, goes to position 3, and that's, instead of doing a line here and a line here, we say, okay, position 1, and then we move to position 2, so what's the velocity we had at position 2? And then when we go from position 2 to position 3, we say, alright, we pretend we're moving at this velocity, and then fit a quadratic thing, like a parabola, to go from this position and this velocity to this position. And then what that does is that gives us up at that new position, alright, well, what's the velocity along that quadratic equation, which gives us a new velocity for that position. So then, we keep having, so just as the particle moves through whatever animation thing, we're constantly reconstructing a velocity from a, we have an old position and an old velocity, and then we get a new position, and from the old position, the old velocity, and the new position, we draw this quadratic thing, and that gives us, and from that we derive a new velocity. Because particles, they have like really complicated things, so we don't have like a closed form analytic way of saying, okay, what is the velocity of the particle at this point? It's all just various things that are perturbing its position. So we can reconstruct that from fitting a quadratic to it, and that ends up giving us, in theory, a really nice curve. So, you see that. But currently I'm in the middle of doing that. And right now that's not actually working as well as I would like, because I've done something dumb with my math and I'm in the middle of trying to find my math error. So step 1 is getting the quadratics. Step 2 is we're going to rework some of the particles so that instead of just being like a constant rate of emission of like particle every, a particle every, 50 particles per second or whatever, it'll actually be able to base it on distance, so we get a nice even spread of particles as we move. So here's what I've done so far, and I think it's doing the right thing so far, but I also think it's I think there's something gone weird with the velocity, or with the way the particles themselves are aligning to the velocity, maybe. That may actually be doing the right thing and just so actually I've already put in most of the quadratics. Right now I'm just debugging this. So what I'm going to do is go back over to Visual Studio, and I think originally the field in this that was set up as world velocity was not actually a velocity, it was a direction that the particle was moving, and I think some of the code in there was, and I've cleaned that out, and I think some of the code that was in there was sort of built around the idea that it was actually, normalized to unit length instead of actually being, instead of world velocity actually being the world velocity. So I'm just searching through the code to look for where are we using world velocity and are we misusing it anywhere. And I'm going to say, yeah, probably in here where we're doing this. So this right here might be the problem. So in here, set a reciprocal square root fast of and so there's a couple tricks in there. Obviously, reciprocal square root, length squared is a really fast thing to do because it's just x times x plus y times y plus z times z. Then we get the reciprocal of the square root, and that's 1 over the length of the thing. And so we multiply x, y, and z by 1 over the length of the entire thing, and you end up with something that always has a length of 1. So in theory, and reciprocal square root fast gives us something that's accurate to 1 part in 1,000 or so. Actually, 1 part in 1 part in 16,000, and that's close enough for drawing a particle, but it's a little bit faster than actually computing computing the square root. So basically we're just dividing this by the length here, and this might give us something much closer to what we want to see. So start our build up, and we'll see this in a second. while we wait for this very exciting thing to play, I'm going to turn up the music. This band is Obscuriae. They are from their album Aria of Vernal Tombs. They are doing kind of a like medieval influenced atmospheric black metal. Everyone likes medieval influenced atmospheric black metal. They have a harpist in the band, which is cool. Not something you get a lot of. I really need to spend a few days reworking our projects to make our builds much faster. Alright, let's turn the metals down while we're back. And here's the game with our velocity being normalized again. And let's see how that affects things. So that's definitely a different look to things. Okay, so definitely something about the velocity was influencing it there. That was why we were getting the stuff really all squished up like that. So I took a little screenshot here as it was firing off. I just make a full view of my desktop so you can see a little better what I'm doing. Let's see. Okay, add just a full capture of my desktop, I guess. And add some Andrew in the corner. Yeah, everyone likes some Andrew in the corner. Okay. So here's one view of what I'm doing. Got that view. I'm gonna do this a couple more times. So getting a bunch of screenshots of what's actually going on here so I can look at it in a little bit of slow motion. Going through looking for yeah, not seeing any other places that world velocity is getting manipulated in a weird way. But obviously this thing right here, that's not what we want to see. Because especially that weird disjunction there is, you know, look at that and go, what's going on? On the other hand, there's some good stuff going on here, like the way that these things are changing their angle. Here's another one where you can see up close. Like it does look like we're getting some rotation on these as they go through, which is what I was going for, but it's still not where I want it to be. So this may be working, but it may not be working exactly right. But I think what will make it a lot easier for us to see is if I go in and work on the part to make things spawn just at an even rate in distance, it'll probably look a lot better. So while I'm doing this, I'm gonna switch over. By the way, if you haven't seen the new inventory screen, this is pretty nice. Switch over to okay, that's really interesting, because what we're seeing there is that we've got this particle that kind of this one trail is not 100% locking to its parent position. So you can see the arrow goes off, and then there's some lag on part of that trail, so it's possible that's doing the right thing. It's also possible that's doing the wrong thing. Maybe I fixed a bug that was keeping that attached when it shouldn't have been attached. So I need to look into that a little better. Possibly check in with Mr. Crossmeyer on that. Oh, here's an interesting one. I have no idea what's actually going on here. But this thing here, where we are attempting to do a melee attack with the bow, it's like, fuck you, I'm an anteater. Come on, one more time. Yeah. Alright, so again, I think this might get a lot easier to see if I adjust for the low frame rate during the stream by putting in the code to slow things down a little bit. Or to actually spawn particles based on motion. So I'm going to break and do that. Go over to source tree, commit what I've got. Let's make a branch. Oh wait, I already did make a ribbons branch. Work in progress on quadratic particle interpolation. And so now, back to Visual Studio Land. The way particles work is particles are spawners and vice versa, so it's all just sort of a big sack of parameters. So we have this let's see, we have a spawn rate and a burst spawn, and I'm going to add another parameter to that. That's spawn per meter, and that'll be number of particles we spawn per meter of travel. And then we'll go back over to our particle renderable and include some support for that. So So that gets a number of particles to spawn per time, and so we need to get a world distance. So we can get rid of this since we're not using it anymore. So we need to come up with what is our world distance, and that's a super simple thing to do. Or rather just length. That's not really right, because we'd actually like to get the distance along the quadratic curve that we're plotting through here, but... Oh, and also I need to add that, not just make another variable. So, introduced a new particle parameter. Actually, I'm going to be super lazy and take that out. That's how I should do it, but just for debugging purposes, okay, so this is shameful, but it'll just let me see something on the screen quickly. And now I should kind of just see a constant rate of particles coming out of there. And if that's all working, then and only then I'll go back and actually plug this stuff together. And since we're let's see. I always like to give credit where due. Okay, so the game's coming back up with that change in there. So now everything should have a fixed rate of... all the particles should get a fixed rate of spawn by distance instead of by time. So that looks much more even than before. But not completely even. I mean, there's still like this cluster of stuff at the start. Yeah, so that's not sexy, and I'm wondering if this is even running the code that I wrote. um, so we go back to Visual Studio. And at a very helpful breakpoint here. Now the client's just gone into crazy land to try and catch up with the server. Okay, trying to get some more just snapshots of this stuff. So this one right here, that's looking better. Like it's got a more even spacing than we had before, but it's still not really even, I don't think. Like you can see down here at across the bottom edge, we're getting the various particles are spaced together a lot more closely than they are up here at the top. And then like here's an even closer in view of like that. So when we're trying to make these things spaced evenly in distance, obviously that's not working yet. So yeah, first question is why. So I'm going to have a quick look and try and set a breakpoint only on the weapon trail. So what I'm going to do here is set a breakpoint in here that is specifically on with this particle's ID is this magic value. And now I should get a breakpoint only on only on that, and that's not what's happening. Okay, hold on. Who's trying to get my attention? Brittany would like to know if I've committed the memory changes. I am waiting on George's code review. I have asked George if he's okay with me bypassing that. Okay. So anyway. So sometimes this is really pretty, and some of the time this is not pretty at all. Let's see. So what I'm going to do here is I'm going to set a breakpoint on Q for render, triple check the ID. Right now there should not be any particles getting rendered. Now I get the camera focused just down on the character, set this to Q for render, And okay, now we've got the particle back that we actually want. Change this conditional breakpoint to look for that one. Now run the game. Now run this again with the breakpoint set to break only on this particular particle. And what kind of world distance do we get? First time we get 0. Second time through we get 0. Alright, this is not being productive. Okay, code over cam. What's going on here? So I'm just going to put a breakpoint. This equals... No. Don't do that. So I'm slightly at a loss here. Try and give you guys a better view of what I'm actually doing, since I'm all tabbing back and forth between the game and the client a lot. Okay, so I'm going to resort to doing some special custom code, where so let's say if particle resource ID equals what's the magic ID of this resource, see, do we have a world time passed into here? I want to check that real quick. not? Okay, this should give us like a nice little historical record of all the historical positions that we've had this particle in. And catch up with the chat. How's everybody doing? Yeah, Farmhand, no, it's not a C++ 11 feature that you can do a non-structs on the template. I just got a little bit ambitious. Okay. I always screw up my parameter packs and default initializers. Let's see, does this work? That makes it happy. Probably should be a pushback. And actually, I did something dumb here. Cancel this all out, and actually, no, that probably would have been fine, but I'm going to include a tiny bit more. Just make a slightly bigger record. Okay, I'm going to get a drink because I'm not used to talking this much, and I will be right back, and hopefully we'll have a game up and working when we do. Okay, so let's see what we have in our little history vector here. Okay, so here's our history vector. Hopefully, yeah, you can see all the numbers. It's matrix time. And I'm going to stare at this and try and figure out what's going on and why. So the first thing I just noticed in here is that our frame rate history is really, really uneven and choppy. And that's not ever a thing we want to see. That might be related to VSync being on. Actually, I'm going to briefly pull up the editor and just actually take a look at the particle that has been made in here. Make sure I fully understand what I'm looking at. So, loading up the editor. Editor, what do we got? So here we open up the particle itself. So we get this does a spawn, burst spawn of 1. Which does a no, I'm not playing Doom in the background. Let's see. Unless you're talking about the music. Okay, so looking in at this particle, we are writing this game engine, Diebox. Because we're hardcore. And there wasn't really anything that would let us like support the scale of stuff we wanted. Okay, so let's see. I'm gonna look at the history in here and confine it. Just generate this little history block. In here where I've hacked in my spawner. And secondly, I'm gonna just launch this thing with VSync off. So at least frame rate will be slightly more stable. So now this should only spawn on the rootmost particle. Or sorry, this should only run on the one spawner that has actual tick types that's actually emitting stuff. So I should get a much cleaner history this time around. Now, what I've done is I looked at the particle definition that we had and said, okay, what's the characteristic of, you know, because like it's sort of, we have a particle that spawns another particle that spawns other particles as it moves, and so I wanted to zero this in on the one that actually was continuously spawning stuff as it moved. So that is what I've done by putting this code in the bracket here, so I'll get a history of just that that emitter particle's movements instead of all the particles that are in this this entire tree. Let's go ahead and close the editor. Keep the number of things running at once to a sane level. All right. So let's have a look at our history vector now. I've got a much more stable frame rate. Here's what's interesting. We're actually getting a lot more motion later. Okay, so let's take a look at that one more time. And so here we have this little history of stuff, and okay, so this is the first thing that jumps out at me as, why is our acceleration wrong? That might point towards what is going on with our Oh, I am an idiot. Okay, so I'd pulled I'd pulled this variable out of here, and then I was not actually making a new one in here. So this will probably unruin a whole lot of stuff with the quadratic extrapolation. So what I had was that. Oops. So originally I wrote this code, then I said, oh, but wait, we can't divide by the elapsed time if the time is 0. So then I pulled it out and made this, but I didn't change it to... So yeah, acceleration was never even being recorded, so everything about the quadratics were being screwy and strange. So this should suddenly, all by itself, make things look better and smoother. It's not going to fix the weird extrapolation stuff, but keeping that little history log was useful for this alone. And waiting on the build. Okay, so just to show you that again, now that I've unmuted my mic, um, so this is definitely looking a lot closer to what I wanted to see, um, but it's still not really right, because you can see like it's choppy. There's several things overlaid on each other. So what I'm trying to do is, that was a good one, if I can figure out how to capture it. Just, for some reason, my taskbar seems to fall apart. Okay, so this right here is a great screenshot of what's going on. So we do seem to have like a clear stepping of things along the way, but we don't seem to have and like there is an arc to them, but they're not really following the right arc. They're sort of jagged. And that says that maybe we've got our velocity wrong, like how we step things back in time. And so, and I think I know, just based looking at that, what might be going on over here. I am forgetting to divide something by so look for where am I setting world velocity. I'm just going to add a couple more variables in here. This is just going to be for debugging. last but not least, grab my magic. Okay, so this should give me a little bit more to chew on of exactly how things are getting computed. And what should be happening is that we correct our position. Like, the way we do this is we take the old position, we generate a new world position just based on all the things that the particle is doing. Then we say, based on the old position and the old velocity, predict what the position should be. And then we come up with what is an acceleration that would adjust our position. So now I'm saying, okay, let's actually check that against the math and see if corrected position with that acceleration applied into it is actually going to be exactly the same as the world position. And also, when we generate our new acceleration and our velocity, if we step back in time, does that give us the old position? So here's to hoping. So let's see. It's very possible I'm just doing something dumb. So corrected position. Is within about half a centimeter, which is as good as we're going to get within the limits of floating point math. And then this back position give us back our old world position. The answer is no, no it does not. So that's probably where we are going wrong. Let's see if I can get this. Yeah, that's way off. So clearly my math is dumb. Okay, anyone see my math mistake? um, oh, okay, that's annoying. You can't actually see the watch window when I do that. So these are the numbers I am staring at intensely. Um, I'm going to take a break, and I will come back and look at this in a little bit more detail. I'm going to take like maybe a 20-minute break to just go do a little bit of math on the whiteboard and realize what I'm doing dumb. And I will be right back at about 5 today. Alright, thanks guys. You know, thanks for hanging out. I will be back in about 20 minutes.